So far, we've just been doing area under a curve to the x-axis. But now, we could take two curves. In our first example, we have two parabolas. I don't know where they are, but we're going to figure out that area in between them. So now all of our estimation things that we had up till now are like, it's not close to a rectangle. We can't kind of estimate it very well. How are we going to do that? Well, the idea looks like this. Okay? I'm going to take this black area away. I'm going to add x-axis and y-axis. I don't know where they are, but we'll just pretend they're there. What have we done so far? Well, I could figure out from this red dot to this red dot, draw it straight down, take out a blue crayon, because I love using crayons. Oh, this feels good when you color in crayon. We could figure out that blue area, right? That's what we were just doing. Area under a curve to the x-axis. That would be relatively straightforward if we knew what this value A was and what this value B was. And then I'm going to take out my green crayon. Okay, I'm just going to move my crayon away for a second. Take out my green crayon. Oh, yes. Oh, feels so nice to color in crayon. If you think about it, you can actually smell the wax, and it brings back such good childhood memories. We could figure out that green area too. That would not be too hard, right? That's just the area under the curve from A to B of the green one. And so if I think about my blue area here, and I think about my green area, can you see that if you take the green area away from the blue area, all you'd be left with is that part in between. And so the area between two curves is just the one area to the x-axis, subtract the other area to the x-axis. And what's really awesome about area between the curves is even if I have some nasty looking situation like this, like, oh, some of those areas are negative and some of them are positive, it doesn't matter. It all works out. You just have to do the one, subtract the other, and the negatives and the positives all match each other out, and it gives you the same answer whether your axes look terrible like that or if they were back to normal like this one. And so you no longer have to worry about negative areas and positive areas when figuring the area between two curves. You just have to take one and subtract the other one. Okay? You have to make sure that you do them in the right order. Can you see that the blue area is the bigger one, is the curve that's on top, and the green curve is underneath? So we needed to do the blue one minus the green one. What happens if you don't get them in the right order? Your answer is going to be negative. And instead of redoing the whole question, if you just go, oops, and add absolute value bars all the way back, perfectly fine. Just, oh, I did the wrong one, so I added absolute value bars and just have to change my answer to positive, no problem. Now, can you recognize by just looking at the equations which one is going to be the parabola on top? Is it going to be the green one or the blue one? The blue one. Why? Because it's minus. That one is the one that's opening down. The other one is opening up. So if I want to find that area, the key things are going to be, it's from where to where. How do I find out what those x values are? Other than cheating and looking at the graph and saying, well, it looks like minus 2 to 2. You set each equation equal to each other because it's where the graphs intersect. So in other words, the y coordinates have to be the same and the x coordinates have to be the same. So to find those intersection points, we just set those equations equal to each other. And what do you know? We were right. It's at -2, 2 and +2, 10. The y coordinates really don't matter. You're just really interested in finding out that it's going from -2 to 2. And so now if we find the area under the curve for the red graph and subtract the area under the curve for the blue graph, we will get that highlighted yellow part of the area between the two curves. Right, so now we can find the area. We can subtract the two functions, but instead of integrating them both separately, what we're always going to do is we're going to simplify. Is that all right if I move down to here? We're going to simplify our equation first so that we have less integrals to do, less integration to do, less arithmetic. Because your 2x's cancel out. Is it all right if I slide down to step 2? Not quite. We can evaluate, plug in all those numbers, and simplify. And it's pretty cool. 64/3 units squared. Just imagining we found that area between two parabolas. I don't know. It's just, for me, just thinking about the fact of what we just did is just really enjoyable, because that shape was not an easy shape, right? It's less satisfying than finding the area of a rectangle. I don't know. I don't get that excited teaching grade 9s. Ooh, it's length times width. Yeah, it doesn't. But this, 2 hours ago, if you would have seen this picture, you'd be like, that is next to impossible to find it out nicely. I could estimate, but I just feel like, but now with integration, we have all sorts of weird shapes. I'm already excited. We don't get to it today, but the next idea we look at is taking shapes like this and rotating them 360 degrees around the x-axis to make volumes. So you could like take a shape like this one, rotate it around, it will be some funky looking donut. Can you imagine that? And you can find the volume of that funky looking donut. It's really cool. Anyways, that's what we're getting to after the areas between curves. I've got like you can figure out the volume of that bell that gets shaped. Really cool. Anyways, sorry, getting excited. We're not there yet. Let's do another area between two curves. This time we have a line and a parabola. Without seeing the graph, which function is going to be on top, which function is going to be below? The line is up top because the parabola is opening up. And it does not matter that some of the area is below the x-axis and some is above, and some of those things have negatives and some of them have positives. It's all just going to work out. Find out where they intersect. Set up your definite integral. It's the line minus the parabola. And simplify. Those are some squeaky shoes. Mm-hmm. You can plug in, to get the y value, you could plug it into either equation, right? Because it's where they intersect, so we found this point and this point. Whether I plug it into the red or I plug it into the blue, it's still the same point, right? Did we need the y coordinate? Again, no. We just needed the x coordinate of -1 and 4. And now we can evaluate it. Again, I've just got the answer there for you. You could plug things in and subtract and find that as well. So the last one I want you to try on your own. I'll put up the answers on Monday. Actually, I'll put up the answers so quickly on here so that if you want to check, if you do it on your own, and you're wondering if you did it right, I'll just add it to the video at the end so you can check. You'll probably have to pause this video because I'm stopping it.